Hello, good morning to all. I am Bhaskar from Erode Engineering College, Assistant Professor of Mathematics. So, we will discuss matrices. So, first one, characteristic equation. Let capital A be a given matrix. Let lambda be a scalar. The equation determinant of A minus lambda I equals to 0. Or determinant of A minus lambda I equals to 0. So is called the characteristic equation of the matrix capital A. So solved problems. So first one problem, find the characteristic equation of A equals to 1 minus 1 0 1. This is 2 into 2 matrix. So first you write characteristic equation formula. The formula is determinant of A minus lambda I equals to 0. So A already given. So I is a identity matrix. So 1 minus determinant of 1 minus lambda minus 1 0 1 minus lambda equals 0. So multiply the values 1 minus lambda into 1 minus lambda whole square. So 0 into 1, so 0 equals to 0. So 1 minus lambda the whole square equals 0. So 1 minus lambda mean A minus B the whole square form. Okay, A minus B whole square formula A square plus B square minus 2AB. So lambda square minus 2 lambda plus 1 equals to 0. Next one problem, find the characteristic equation of A equals to 1, 2, minus 3, 4. Solution, let capital A equals to 1, 2, minus 3, 4. So this is 2 into 2 matrix. The characteristic equation is determinant of A minus lambda I equals to 0. So the A is matrix already given, 2 into 2 matrix. So I is the identity matrix. So determinant of 1 minus lambda 2 minus 3 4 minus lambda equals 0. So 1 minus lambda into 4 minus lambda, multiply the values 1 minus lambda into 4 minus lambda plus 3 into 2 6, already 1 minus minus of minus plus equals 0. So multiply the values 4 minus lambda minus 4 lambda minus of minus plus plus lambda square plus 6 equals 0. So adjust the equations, lambda square minus 5 lambda plus 10 equals to 0. So this is characteristic equations. Next one, solved problems. So this is 3 into 3 matrix. Find the characteristic equation of A equals to minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. So this is 3 into 3 matrix. So already discussed 2 into 2. Now we will discuss 3 into 3 matrix. So the solution, let the characteristic equation is lambda cube minus A1 lambda square plus A2 lambda minus A3 equals to 0. So this is formula for find out the characteristic equation. So where A1 equals to sum of leading diagonal elements equals to, the leading diagonal elements means minus 2, 1, 0. So this is diagonal values. So A1 equals to minus 1. Next A2 equals to sum of the minors of the leading diagonal elements. Minors of the leading diagonal elements mean, so minus 2. So 1 minus 6, 2 minus 2, 0. Plus determinant of, this is diagonal value, minors of diagonal value, leading diagonal values. So minus 2, minus 3, minus 1, 0. So this is leading diagonal of minor values. So minus 2, 2, 2, 1. So adjust the values, 1 into 0, 0. So 2 into 6, 12. Already 1 minus, so minus 12 plus 0. 2 into 0, 0. 1 into 3, minus 3. Already 1 minus, so minus 3. Plus 1 into 2, minus 2. So 2 into 2, 4. So already 1 minus, so minus 4. So equals to minus 21. So next A3 equals to determinant of A. So determinant of A minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. Okay, so take minus 2 values. So multiply the values. 1 into 0, 0. So 2 into 6, 12. Already one minus. So minus 12. Minus 2 of 0 minus 6 minus 3 of minus 4 plus 1. So adjust the values. 24 plus 12 plus 9 equals to 45. This is A3 values. Put A1, A2, A3 values in further formulas. So lambda cube plus lambda square minus 21 lambda minus 45 equals to 0. This is characteristic equation. So next topic, eigenvalue and eigenvectors. The basic definitions. First one, eigenvalues. The value of lambda obtained from the characteristic equation determinant of A minus lambda I equals to 0 are called values of A. So next one, eigenvector. Let capital A be a square matrix of order 3 and lambda be a scalar. This is eigen, means eigenvalue. The column on matrix X equals to x1, x2, x3, which satisfies A minus lambda I into x equals 0 is called eigenvector of the matrix. This is basic conditions for let capital B the matrix, capital A be the matrix whose columns are eigenvector of A. First one, if determinant of A equals 0, then the eigenvectors are linearly dependent. Second one, if determinant of A not equal 0, then the eigenvector are linearly independent. So first problem, find the eigenvalues and eigenvector of the matrix. A equals to 4, 1, 3, 2. So this is 2 into 2 matrix. So first one solution. First step 1, to find characteristic equation and eigenvalues. The characteristic equation formula, determinant of A minus lambda I equals to 0. So A already given, I is a identity matrix. So 4 minus lambda 1, 3, 2 minus lambda equals to 0. So 4 minus lambda into 2 minus lambda, multiply the values, and 3 into 1. So minus 3 equals to 0. So multiply the values. 4 into 2, 8. 4 into minus lambda, 4 lambda, minus 4 lambda. So minus lambda into 2, minus 2 lambda, minus lambda into minus lambda, lambda square, minus 3 equals 0. Adjust the values. Lambda square minus 6 lambda plus 5 equals to 0. So lambda minus 1, lambda minus 5 equals 0. So lambda equals to 1 and 5. The lambda values 1 and 5. The eigenvalues are 1 and 5. Step 2. To find eigenvectors. The eigenvector x equals to x1, x2 is given by the equation A minus lambda I x equals to 0. So 4 minus lambda 1, 3, 2 minus lambda x1, x2 equals 0. So 4 minus lambda into x1 plus x2 equals 0. 3x1 plus 2 minus lambda x2 equals to 0. So first case 1. Already find out lambda value. So first you take first one value. When lambda equals to 1, we get 3x1 plus x2 equals 0. 3x1 plus x2 equals to 0. So x2 equals to minus 3x1. Put x1 equals to 1. x2 equals to minus 3. So x1 equals to 1 minus 3. This is first one value. Case 2. Lambda equals to 5. We get minus x1 plus x2 equals 0. So x1 equals to x2. 3x1 minus 3x2 equals 0. So x1 equals to x2. So x1 equals to k, x2 equals to k. Put k equals to 1, x1 value 1, x2 value 1. So x2 value 1, 1. The matrix is 1, 1. So conclusion, this is characteristic equation, eigenvalues, eigenvectors. So characteristic equation, lambda square minus 6 lambda plus 5 equals 0. So lambda 1 equals to 1, lambda 2 equals to 5. So x1 equals to 1 minus 3, x2 equals to 1, 1. Thank you.